Scott's primary school in Essex uses techniques pioneered by maths specialist Richard Dunn to teach children geometry. Gary Clapperton has used these techniques in teaching his Year 6 class about explicit and implicit shapes, angles and ratio. But how easy was it for the children to identify the geometric shapes in the photos they'd taken? Was the interactive whiteboard a useful tool in teaching the lesson? And why did Gary have all the desks arranged in neat rows facing the front? Just some of the questions raised when head teacher and maths specialist Petula Allen discusses the lesson with Gary in the lesson review.
There was a number of things that I was very impressed with. I was very impressed with the children's, their use of vocabulary,
yes.
Their knowledge of the properties of shape, when they refer to vertices, vertex, parallel lines.
What do we call the corners of shapes? Jack?
Vertices.
Good boy, vertices. But that's the plural. If we've got just one corner in maths of a shape, what do we call it? Stanislav?
Vertex.
Very good.
Yes, I was particularly pleased with all that work, which was revision work, and how well they remembered all of that, yes.
And their concentration, the way they cooperated with each other. And for me, the way you linked real-life experiences to the mathematical properties
yes.
of shapes really brought the lesson alive to me.
I was pleased with that because that was the first for me. I've never actually linked it to real life that closely before, so I was pleased with that as well, yes.
Yeah. There was one part where the rectangle that you were referring to, right at the very beginning, you showed the children just how, by altering the size
yes.
of the rectangle on the whiteboard, it made no difference to the ratio of the sides
yes.
or the properties of the rectangle.
If I move it around, the angles are still right angles. The sides are still the same ratio. I can turn the shape and it's still the same. Same ratio of sides, same right angles. I can even spin it round. Even though I'm a bit dizzy, I can still see it's the same shape. I could even make it smaller.
I felt that was very powerful because children often get very confused.
I think that does show how powerful the whiteboard can be. I can think of no other way of illustrating that as powerfully as you can on the whiteboard.
Mm.
Still got 4 right angles. Still the same ratio of 1 to 2.
During the children's discussion about the implicit
yes.
and explicit shapes, and the way you moved around the classroom and talked to the children, yes. The way you'd arranged the furniture facilitated
yes.
that with ease. Is that one of the reasons why you have your desks arranged like that?
I do have my desks arranged so I can, in this sort of lesson, move around very easily and see what they're doing. But also in this sort of lesson where I knew I was going to use the whiteboard an awful lot, I wanted them all to be facing the front, so they would have to turn around. They could all see the whiteboard very easily. But of course, obviously, in other lessons where I'm not using the whiteboard, we've got plenty of room. We can shift the desks around into little groups or whatever, or sometimes we have to push them back completely out of the way. It's very, very versatile.
Who would like to come and show us on the whiteboard an explicit shape? Here, Michael, show us your shape.
Now that's good to watch. Just seeing the confidence of the children going up to the whiteboard,
yes, yes,
drawing
yes.
those shapes, that struck me.
Yeah. And they're always so eager to be out there using it.
I know.
It makes so much difference. Very motivational tool.
And there's Jack, when it was too high
yes,
for him
yes.
to reach, and
Pulled it down.
he
Yes.
pulled it down.
Yeah.
I wondered how you were going to
Yeah.
cope with that.
Again, that helps. I mean, in the old days when you had a blackboard, the child could not reach to the top of the blackboard. You just could not do it.
I think there's a bit coming up now where you're asking the children to estimate
Oh, yes.
the angle in the triangle, and I was really surprised by Jacob's
Yes.
first answer.
Roughly, what would you say that angle is there? Jacob?
100 degrees.
100 degrees. So you think it's more than 90 degrees?
Yes.
Who thinks it's less than 90 degrees?
When he came out with 100 degrees, that did throw him a little bit. I expected him maybe to say lower. I wasn't expecting higher than 90 degrees. So that threw me a little bit there. But then I think if you look, I asked Lauren, and she went completely the opposite way. Although she went below 90, she went 45.
What do you think is the size of this angle then, Lauren?
45 degrees.
Who thinks 45 is too small?
I must admit, I panicked a bit in terms of, because I know you've done a lot of work with the children on angle, and I know children traditionally find estimation of angle difficult. So even though you've done all of that work, we came up with those two
I thought
answers.
Lauren would have been much closer than that. Yes.
Yeah. It was interesting when Greg moved towards 80.
Yes.
And then I think, was it Jack?
Yes.
That said something about 75. And they seemed to be referencing to 90 degrees.
Yes.
And I wondered if that would help them, that sort of reference to 90 degrees.
What do you think, Greg?
80 degrees.
Who agrees with Greg? It's about 80 degrees. So do I. Only roughly, about 80 degrees. What do we think approximately is the size of this angle? Jacques?
75 degrees.
About 75 degrees. Why do you think that?
Because it's smaller than the other angle.
OK, it's slightly smaller than the other angle. Who agrees with Jacques? About 75 degrees. Good.
If you go back to where Jacob said 100, I think I jumped in straight away and said, do you think it's more than 90 degrees?
Yeah,
it would have been much better if I'd said to him, how did you work out it was about 100? And let Tim then develop the idea of more or less than 90.
I think you're right. It would have given him a clue. There was another point that I was puzzled with, surprised that you didn't link up with. You asked the children...
Oh, yes. I remember this bit as well, yes.
You remember you asked them what sort of triangle it was?
I know what you're going to say, yes.
What can you tell me about Jack's shape? Matthew?
It's an isosceles triangle.
Very good. It's an isosceles triangle.
And then we had all this bit of estimation of angle. And when they'd settled on 80 degrees, and then you went and asked them to estimate the second angle, well, just run by me what was going on there.
The first thing is, this is the first time I've actually used shapes which are not under my control. Right. Usually I draw shapes or get them somewhere else. Because you're using explicit shapes from photos, you're not in control of what's coming up, especially if the children could just pick any one they like. And you obviously did get some triangles there which were really borderline between isosceles and scalene triangles. And you're quite right. I think someone said it was an isosceles triangle. I said, yes, it is. Then later on, when we realised it was about 75 and 80 degrees, the two angles, obviously it was not isosceles. I missed an opportunity there to say, right, let's go back and look at what we said. Is it isosceles? And then say, well, no, if it's about 75 or 80 of those two angles, it must be a scalene triangle. Now this is Billy. And he had quite a difficult picture here. Now, I thought when he came out, he was just going to do the rectangle.
I did too.
Yes, and I was going to then make him do another shape afterwards, but he didn't. He threw me a little bit and went for the triangle first, and then the second one he did was the rectangle.
Here you are. Shall I say shape? Good. Don't go away. But show us another one now.
Yeah, I was really surprised by that, because it was covered with rectangles, and he chose that right angle triangle.
Obviously, they were told to find 4, and he had found several. But I thought when he first came out, he would go for the obvious.
Easy. What is it? George?
It's a rectangle?
Yes, it's a rectangle. Good.
There was a point where Stanislav had found a shape, and he'd just partitioned it anywhere. And there's no real reason why he had partitioned it a certain way.
So Stanislav, show me this implicit shape you've drawn on here.
There.
And what is it?
A trapezium.
Good. Would it be better, though, to maybe join the diagonals? Because this line here you could put almost anywhere. You could do this from infinity along there, couldn't you?
Yeah.
Have a go at that.
It wasn't wrong. But I was trying to get over to him, it might be better if he was to draw diagonals to bring out the explicit shapes.
I'm not quite with you. Can you just do a little
yes,
sketch for me?
if I just sketch this. This is the shape that Stanislav, the explicit shape Stanislav had found, the trapezium.
That's the explicit one.
That's it. And he had just partitioned it down the middle to give these two implicit shapes.
So he hadn't referred to the vertices?
No. I was trying to get him to refer to the vertices, which would be much more helpful in the later work we're going to be doing.
So in a sense, he'd gone beyond your expectations from the teaching point of view. And I suppose you weren't really
No, I was
prepared.
expecting them to be doing diagonal lines, or maybe even drop a perpendicular from the vertices to make a right angle there.
And where do you think this work on implicit shapes could lead to?
I mean, this, in a way, gives you a clue to where we could go next. For example, if they're trying to find areas of odd shapes like rooms, if you have a room this shape, they can then look for the implicit shapes and partition this to find the area much more easily.
It's just that sort of
Yes,
thing that
yes.
children find very difficult.
It is.
Gary, I know that's a mixed ability class that you have. I also know that there's a very wide range
Yes.
of ability. Can you tell me, just run by me, how you manage that within the context of the lesson?
The main thing that helped with the lesson was having Kathy there. She had a small group to look after and help, as you can see. And from what I could see that was going on, she was doing extremely well. I did not have to really intervene at all. She was doing some very nice things with them. I think they got quite a lot out of it.
Look, they're really enjoying that bit.
Yes, although they took these photos themselves, this is actually the first time they've actually seen them. And I think it does help that they're using photos of things they've seen around the school to help them link the math story, when we actually draw the shapes, to the real life story in the photos.
Yeah, but that's an implicit shape. That's an explicit one. Yeah, do that one. This one, it's another trapezium, but no.
The real life story is actually the buildings or things they've seen, but also we can call the photos the real life story. When we start drawing these shapes on the photo, that's the real story. But then when we completely take the shape away, so it's completely on its own, that is the math story.
So they've just got the mathematics, they've just got the mathematical shape there with its properties and knowing that. That's
Although the important thing here is we've got to realise that in real life there are shapes all around them.
I think
that link.
That definitely came across.
Yes.
And the children really picked that up. And again, I was quite surprised by that.
Yeah. I think one thing the lesson does show that real life helps to make sense of maths, but also that maths helps to make sense of real life.
When you're drawing shapes from real life, what do you have to think about?
The ratio of the sides, the angles.
Well done.